Today we're going to study distance between 2 points. Let us define the distance between 2 points. The distance between 2 points is the length of the straight line between those 2 points. I have here 2 points, and let us name these 2 points. The first point is P sub 1 with coordinates x sub 1 and y sub 1. The other point is P sub 2 with the ordered pair x sub 2, y sub 2. Let us connect these 2 points, and the distance between these 2 points is the length of this straight line. Let us draw a horizontal line segment that will pass through P sub 1, and it's here. Also, let us drop a vertical line segment that will pass through P sub 2. By doing this, we will form a right triangle here. Let us name the sides of this right triangle. In the rectangular coordinate system, this side here can be named as x sub 2 minus x sub 1. Also, the side here, considering the ordered pair of the P1 and P2, this side is y sub 2 minus y sub 1. By the triangle here, the D corresponds to the hypotenuse of the right triangle. So by the Pythagorean theorem, the square of the hypotenuse, which is the D, here we write D square, is equal to the sum of the squares of the two other sides. Let us write first this side, and we square this. So we write here x sub 2 minus x sub 1, and it is squared, plus the side here is the y sub 2 minus y sub 1. The quantity is squared. And to make this D without the square, we will take the square root of both sides. And this is now what we call the distance formula between 2 points. Let us have example 1. Calculate the distance between the points -3, -1, and -2, 4. Let us assign the first point to be the P sub 1 with the ordered pair x sub 1, y sub 1, and the second point to be P sub 2 with the ordered pair x sub 2, y sub 2. Then our distance formula is written here. Let us start substituting the values for our distance formula. Our x sub 2 is -2, then minus the x sub 1, which is -3. This group is now squared, and then plus the y sub 2 is +4, then minus y sub 1 is -1. This group is squared. Then let us simplify further. Let us remove the grouping symbol for its x and y's. So the -2 here is without the parenthesis. Then the minus and the negative becomes +3. The square is there. Then plus. The parenthesis of 4 is removed here. The minus and the -1 becomes +1. And again, we don't forget to write the square. Then we simplify further on the next step. The -2 plus 3 is now +1. And we copy the power 2, then plus 4 plus 1 is 5 square. Then we simplify the square now. 1 square is 1 plus the 5 square is 25. So 1 plus 25 is 26. So the distance is equal to the square root of 26. We put the word units, and this is our final answer. There is a question here. What will happen if the p sub 1 and p sub 2 are interchanged? It means, can we use the first point to be p sub 2 and the second point to be p sub 1? Let us solve that one. So I put here the first point to be the p sub 2 and the second point here to be p sub 1. Let us solve using our distance formula. Let us substitute the values. The x sub 2 is the negative 3, then minus x sub 1 is negative 2. Of course, we write the square, then plus y sub 2 is negative 1, then minus y sub 1 is positive 4. Then let us simplify this equation. We remove the grouping symbol from negative 3. It is now written here. The minus and the negative 2 becomes plus 2. We write the square, then plus. We remove the grouping symbol from negative 1. It is now negative 1 here. Then minus of this positive 4. So we remove the grouping symbol. And the square is copied. Then we simplify further. The negative 3 plus 2 becomes negative 1. Then the square is there. Plus negative 1 minus 4 is negative 5. The power 2 is copied. And then we simplify on the next step. The square of negative 1 is positive 1. The square of negative 5 is positive 25. So 1 plus 25 is 26. So our distance is equal to the square root of 26. This is our final answer. Our answer to the question is, when we use the first point to be p sub 1 and the second point to be p sub 2, or vice versa, the derived distance will be the same. Let's have example 2. Calculate the distance between negative 5, 3 and negative 9, 6. Let us assign the points. Let this be the p sub 1 and the other point to be the p sub 2. Our distance formula is here now. Let us substitute the values. Our x sub 2 is negative 9 minus x sub 1 is negative 5. We put the square and then plus. The y sub 2 is positive 6 minus the y sub 1 is positive 3. And we put the power 2. Then we simplify further. We remove the grouping symbol of negative 9. It's now without the parenthesis here. The minus and the negative 5 becomes plus 5. We copy the square. Then plus. We remove the parenthesis for the 6 and for the 3. The minus sign is simply copied here. Then we simplify further. The negative 9 plus 5 is negative 4. And then that is squared plus 6 minus 3 is 3. We copy the power 2. Then we simplify again. The square of negative 4 is positive 16 plus the square of 3 is 9. 16 plus 9 is 25. And we can simplify the square root of 25 to be 5. And our answer for the distance is 5 units. Example 3. Prove that the points P, which is 3, 2, point Q, negative 2, negative 3, and point R, and that is 2, 3, form a right triangle. Let's write the distance formula. Let's begin with the side PQ. Using the distance formula, we have now 3 minus negative 2, that is squared, plus positive 2 minus negative 3, then we will square. Let us simplify the radicand. This 3 minus negative 2 will be positive 5, then we will square later. Plus 2 minus negative 3 is positive 5 that we will square. Now the square of 5 is 25 plus 5 square is also 25. 25 plus 25 is 50. So for the PQ, we have square root of 50. Next, the side QR. By distance formula, we write negative 2 minus 2, then we will square, plus negative 3 minus positive 3, then we will square. Let us simplify the radicand. Negative 2 minus 2 is negative 4, then we will square, plus negative 3 minus 3 is negative 6, then we will square. The square of negative 4 is 16, plus square of negative 6 is 36. The sum of 16 and 36 is 52. So for the QR, the answer is square root of 52. Next, side PR. By distance formula, we have now 3 minus 2, that is squared, plus 2 minus 3, that is squared. Simplifying further, 3 minus 2 will be 1, that will be squared, plus 2 minus 3 is negative 1, then we will square. 1 square is simply 1, square of negative 1 is 1. 1 plus 1 is 2. So for the side PR, the answer is, or the distance, square root of 2. Since the square of side PQ plus the square of side PR equals the square of side QR. To show this, we can substitute the corresponding values. So, square of PQ will be square of square root of 50 plus the square of PR will be the square of square root of 2 equals the square of side QR is the square of square root of 52. Then we cancel the radical with a corresponding exponent. We have now 50 plus 2 equals 52. Then the left side is 52 equals right side, which is 52. By the converse of Pythagoras theorem, we have an angle P that is 90 degrees. Therefore, the triangle PQR is a right triangle. Example 4. Show that the points A, 1, 7, point B, 4, 2, point C, negative 1, negative 1, and point D, negative 4, 4, are the vertices of a square. Let us show that all sides are equal and show that the two diagonals are equal, so that the 4 points here are vertices of a square. Let's write the distance formula. Then we have the 4 sides. Let's begin with the side AB. By distance formula, we have now this 1 minus 4, that is squared, plus 7 minus 2, then we square. 1 minus 4 is negative 3, and then squared, plus 7 minus 2 is 5, then we will square. The square of negative 3 is 9, plus 5 square is 25. The sum is 34. So for the side AB, It is square root of 34. Now, side BC. By distance formula, we substitute the values as 4 minus negative 1, then we will square, plus 2 minus negative 1, then we will square. This 4 minus negative 1 will be 5, that is squared, plus 2 minus negative 1, that is 3, then we will square. 5 square is 25, plus 3 square is 9. 25 plus 9 is 34. Therefore, for the side BC, the length is square root of 34. What about the side CD? By distance formula, we have the values negative 1 minus negative 4, that is squared, plus negative 1 minus 4, that is squared. Negative 1 minus negative 4 is positive 3, then we will square, plus negative 1 minus 4 is negative 5, then we will square. 3 square is 9, plus square of negative 5 is 25. 9 plus 25 is 34. Therefore, the length of the side CD is square root of 34. Then the side DA. By distance formula, it becomes negative 4 minus 1, that is squared, plus 4 minus 7, that is squared. Negative 4 minus 1 is negative 5, that is squared, plus 4 minus 7 is negative 3, that is squared. The square of negative 5 is positive 25, plus square of negative 3 is positive 9. 25 plus 9 is 34. For the length of DA, we have square root of 34. We can see that the sides are equal in length, which is square root of 34. Now, the two diagonals. The first diagonal is from points A to point C. So this is AC. By distance formula, we write 1 minus negative 1, that is squared, plus 7 minus negative 1, that is squared. 1 minus negative 1 is 2, that is squared, plus 7 minus negative 1 is 8. Then we will square. 2 square is 4, plus 8 square is 64. 4 plus 64 is 68. AC is with length square root of 68. What about the length of BD? This is the second diagonal. By distance formula, we write 4 minus negative 4, that is squared, plus 2 minus 4, that is squared. 4 minus negative 4 is 8, then we will square, plus 2 minus 4 is negative 2, then we will square. 8 square is 64, plus negative 2, that is squared, is positive 4. 64 plus 4 is 68. So for diagonal BD, the length is square root of 68. Since the side AB is equal to the side BC equals the side CD and the side DA. Also the diagonals AC equals BD. Then the 4 points are the vertices of a square. Example 5. In a classroom, Ashima, Bharti, and Camelia are seated at point A 3-1, point B 6-4, and point C 8-6 respectively. Prove that they are seated in a line. To prove this, let us show that AB plus BC equals AC, so that the girls are seated in a line. We write the distance formula. We start with the length AB. So we have the square root of 3 minus 6, that is squared, plus 1 minus 4, that is squared. 3 minus 6 is negative 3. We will square, plus 1 minus 4 is negative 3. Then we will square. Negative 3 squared is 9, plus Negative 3 squared is also 9. 9 plus 9 is 18, and we can simplify this into 9 times 2. This 9 is a perfect square number that we can pull out outside the radical sign. So we have 3 square root of 2 for the length AB. What about the length BC? By distance formula, we have 6 minus 8, that is squared, plus 4 minus 6, that is squared. 6 minus 8 is negative 2, that we will square, plus 4 minus 6 is negative 2, that we will square. Square of negative 2 is 4, plus square of negative 2 is also 4. 4 plus 4 is 8. This 8 inside the radical sign, we can show that this is 4 times 2. This 4 being a perfect square number, we can pull out of the radical sign. So this is simplified into 2 square root of 2. Now for AC. By distance formula, we write 3 minus 8, that is squared, plus 1 minus 6, that is squared. 3 minus 8 is negative 5, that we will square, plus 1 minus 6 is negative 5, that we will square. Square of negative 5 is 25, plus 25. The sum is 50. We can simplify this as 25 times 2. This 25 is a perfect square number. We can simplify to pull it out of the radical sign. So this is 5 square root of 2. Now let us show that AB plus BC equals AC. When we substitute the values, we have 3 square root of 2 plus 2 square root of 2 equals 5 square root of 2. The left side becomes 5 square root of 2, which is equal to the value of the right side. Since AB plus BC equals AC, then the girls are seated in a line. Hi everyone, today we're going to study section formula. Let us have this line segment. The endpoints are A and B. Point A has coordinates x sub 1, y sub 1. Point B with coordinates x sub 2, y sub 2. Then we have point P between A and B, and this point P with coordinates x, y. So the coordinates of the point P with coordinates xy, which divides the line segment joining the points A and B internally, in the ratio m sub 1 is to m sub 2 r. This is the coordinates. For the x coordinate, m sub 1 times x sub 2 plus m sub 2 times x sub 1 all over m sub 1 plus m sub 2, for the y coordinate, m sub 1 times y sub 2 plus m sub 2 times y sub 1 all over m sub 1 plus m sub 2. This is known as the section formula. If the ratio in which P divides AB is k is to 1, then the coordinates of the point P will be k times x sub 2 plus x sub 1 all over k 1, k times y sub 2 plus y sub 1 all over k plus 1. The midpoint formula is a special case of the section formula. Example 1. Find the coordinates of the point which divides the line segment joining the points 4, negative 3, and 8, 5 in the ratio 3:1 internally. Let P, X, Y be the required point. By section formula, the X coordinate will be M sub 1 times X sub 2 plus M sub 2 times X sub 1 all over M sub 1 plus M sub 2. When we substitute the corresponding values, we have 3 times 8 plus 1 times 4 all over 3 plus 1. The numerator becomes 24 plus 4 over the denominator 4. In the numerator, the sum is 28 divided by the denominator 4, and that is 7. That is the X coordinate. For the Y coordinate, this is our formula. M sub 1 times Y sub 2 plus M sub 2 times Y sub 1 all over M sub 1 plus M sub 2. When we substitute the values, we have 3 times 5 plus 1 times negative 3 all over 3 plus 1. The numerator is simplified as 15 minus 3 all over the denominator 4. In the numerator, the difference is 12 divided by the denominator 4, and the quotient is 3. Therefore, the point 7,3 is the required point. Example 2. Find the coordinates of the points of trisection, that is, points dividing in 3 equal parts of the line segment joining the points A, 2, negative 2, and B, negative 7, 4. Let P and Q be the points of trisection of the line segment AB, and that is AP equals PQ equals QB, as we can see in this figure. Now, for the point P, it divides AB internally in the ratio 1:2. Therefore, the coordinates of P are, this is the X coordinate, 1 times negative 7 plus 2 times 2 all over 1 plus 2. And the Y coordinate, 1 times 4 plus 2 times negative 2 all over 1 plus 2. We can simplify further into the X coordinate becomes negative 7 plus 4 over 3. For the Y coordinate, it becomes 4 plus negative 4 over 3. We simplify the X coordinate. Negative 7 plus 4 is negative 3. Divide by 3, that is now negative 1. For the Y coordinate, 4 plus negative 4 is 0. Divide by 3 is 0. So this is our coordinates of P. Now for the Q. Q divides AB internally in the ratio 2:1. The coordinates of Q now are 2 times negative 7 plus 1 times 2 all over 2 plus 1. And the Y coordinate, 2 times 4 plus 1 times negative 2 all over 2 plus 1. We can simplify further. The X coordinate becomes negative 14 plus 2 all over 3. And the Y coordinate is 8 plus negative 2 over 3. We simplify the X coordinate. Negative 14 plus 2 is negative 12. Divide by 3 is negative 4. For the Y coordinate, 8 plus negative 2, and that is 6. 6 divided by 3 is positive 2. This is the coordinates of Q. Example 3. In what ratio does the point negative 4, 6 divide the line segment joining the points A, negative 6, 10, and B, 3, negative 8? Let negative 4, 6 divide the line segment AB internally in the ratio m sub 1 is to m sub 2. We will use our section formula and it becomes like this. The negative 4, 6 equals m sub 1 times 3 plus m sub 2 times negative 6 over m sub 1 plus m sub 2 for our x coordinate. For the y coordinate, it becomes m sub 1 times negative 8 plus m sub 2 times 10 all over m sub 1 plus m sub 2. Now let us consider the x coordinate. We take the negative 4, also this fraction we copy here. Then we cross multiply this denominator to the left side value. So the left side becomes negative 4 times m sub 1 minus 4 times m sub 2 equals the numerator of this fraction. Let us simplify this equation by putting all like terms in one side. It means this 3 m sub 1 we transpose to the left. This negative 4 m sub 2 we transpose to the right. And it becomes like this. When we simplify, the left side becomes negative 7 m sub 1 equals the right side negative 2 times m sub 2. Both sides are negative. We can multiply this by negative 1. So it becomes positive. So we have 7 m sub 1 equals 2 m sub 2. We can rewrite this equation as m sub 1 over m sub 2 equals 2 over 7. So we can see that m sub 1 equals 2 and m sub 2 equals 7. Therefore, the ratio is 2 is to 7. This is the answer. Same ratio will come when y coordinate is used. Hi everyone. Today we're going to study area of a triangle. Let ABC be any triangle whose vertices are point A, x sub 1, y sub 1, point B, x sub 2, y sub 2, and point C, x sub 3, y sub 3. Then the area of triangle ABC is the numerical value of the expression 1/2 times the quantity x sub 1 times the group y sub 2 minus y sub 3 plus x sub 2 times the quantity y sub 3 minus y sub 1 plus x sub 3 times the quantity y sub 1 minus y sub 2. Example 1. Find the area of a triangle whose vertices are 1, negative 1, negative 4, 6, and negative 3, negative 5. We have the formula of the area. Let us substitute the corresponding values. So we have 1/2 times the quantity 1 times the quantity 6 minus negative 5 plus negative 4 times the quantity negative 5 minus negative 1 plus negative 3 times the quantity negative 1 minus 6. Let us simplify further. 6 minus negative 5 is 11 times 1, that is positive 11. Negative 5 minus negative 1 is negative 4. Multiplied by negative 4, it becomes positive 16. Negative 1 minus 6 is negative 7 times negative 3, that is positive 21. The sum 11 plus 16 plus 21 is 48. And 1/2 times 48 is 24. So the area is 24 square units. Example 2. Find the area of a triangle formed by the points A, 5, 2, B, 4, 7, and C, 7, negative 4. We have the formula of the area. Let us substitute the corresponding values. So we have 1/2 times the quantity 5 times the quantity 7 minus negative 4 plus 4 times the quantity negative 4 minus 2 plus 7 times the quantity 2 minus 7. Let us simplify further. 7 minus negative 4 is positive 11 times 5 is positive 55. Negative 4 minus 2 is negative 6 times 4 is negative 24. 2 minus 7 is negative 5 times 7 is negative 35. When we simplify 55 minus 24 minus 35, that is negative 4. And 1/2 of negative 4 is negative 2. Since area is a measure which cannot be negative, we will take the absolute value of negative 2, that is positive 2. Therefore, the area of the triangle equals 2 square units. Example 3. Find the area of the triangle formed by the points P, negative 1.5, 3, Q, 6, negative 2, and R, negative 3, 4. We have the formula. Let us substitute the corresponding values. We have 1/2 times negative 1.5 times the quantity negative 2 minus 4 plus 6 times the quantity 4 minus 3 plus negative 3 times the quantity 3 minus negative 2. When we simplify further, negative 2 minus 4 is negative 6 times negative 1.5. That will be positive 9. So 4 minus 3 is 1 times 6, that is positive 6. 3 minus negative 2 is 5 times negative 3, that will be negative 15. 9 plus 6 minus 15 is 0. And 1/2 of 0 is 0. So the area is 0 square units. If the area of a triangle is 0 square units, its vertices are collinear. Example 4. Find the value of k if the points A, 2, 3, B, 4k, and C, 6, negative 3 are collinear. Since the given points are collinear, the area of the triangle formed by them must be 0. So we have this formula. When we substitute the values, the left side or the area is now 0. Then we substitute the corresponding values based on the points. So we have 1/2 times the quantity 2 times k minus negative 3 plus 4 times the quantity negative 3 minus 3 plus 6 times the quantity 3 minus k. When we simplify further, this k minus negative 3 is k plus 3 times 2, it becomes 2k plus 6. This negative 3 minus 3 is negative 6 times 4, that becomes negative 24. 6 times 3 minus k is now 18 minus 6k. Let us remove the grouping symbols and we combine like terms. Now, this 2k minus 6k is negative 4k. The 6 minus 24 plus 18 becomes 0. Then 1/2 times negative 4k is negative 2k. We divide this equation by negative 2 to get the value of k as 0. Example 5. If A, negative 5, 7, and B, -4, -5, and C, -1, -6, and D, 4, 5 are the vertices of a quadrilateral. Find the area of the quadrilateral ABCD. By joining point B to point D, there will be two triangles, ABD and BCD. Let's begin with taking the area of triangle ABD. Let us substitute the corresponding values to our formula, and it becomes like this. 1/2 times -5 times the quantity -5 minus 5 plus -4 times the quantity 5 minus 7 plus 4 times the quantity 7 minus -5. We simplify further. -5 minus 5 is -10 times -5, that will be positive 50. 5 minus 7 is -2 times -4, that is now positive 8. 7 minus -5, that becomes positive 12, times 4 is now 48. 50 plus 8 plus 48 is 106, and half of 106 is 53. Therefore, the area of triangle ABD is 53 square units. Let's proceed with the area of triangle BCD. Let us substitute the corresponding values in our formula. So we have now 1/2 times the quantity -4 times the quantity -6 minus 5 plus -1 times the quantity 5 minus -5 plus 4 times the quantity -5 minus -6. Then let us simplify further. -6 minus 5 is -11 times -4, that is positive 44. 5 minus -5 is 10 times -1, that is -10. -5 minus -6, that will be positive 1 times 4, that will be 4. And 1/2 of 38 is 19. So the area of triangle BCD is 19 square units. Now for the area of quadrilateral is 53 plus 19 equals 72 square units.